Got some more easy exam points for you here when you look at the frame processing methods and just really look at the names because they're pretty much telling you what's going on. But let's see exactly what we're cutting through and what fragments we're talking about here. Just about everything in networking has pluses and minuses, and that's true with each of these three methods. Now, this isn't something that you and I as network admins really configure. Most Cisco switches are set to a default, which is store and forward. But for the CCENT and CCNA exams, let's know what all three of these methods are and what those pluses and minuses are. Store and forward, I almost feel silly telling you what happens here, but here's what happens. The entire frame is stored by the switch, and then it's forwarded. We need to keep our eye, though, on two particular values in the frame here. That FCS, the frame check sequence value, and the destination MAC address. Now, the FCS, as we know, it allows the recipient to determine if the data was corrupted during transmission. And when store and forward is in use, the storage of the entire frame allows the switch to check the FCS before actually forwarding the frame. Now, this allows the greatest level of error detection of our three processing methods, and we love error detection. We'll take as much of it as we can get. And really, you can see why this is the default on so many Cisco switches. Now, it follows, then, that the other two methods do not store the entire frame before they forward it. With cut-through, what happens here is that the switch reads the MAC addresses on the incoming frame and then begins to forward the frame even as part of it is still being received. We're already kicking it out the back door as it comes in the front door, and the FCS is not checked at all, so there's zero error detection. So just like we needed a middle ground between unicast and broadcast, and we came up with multicast, we definitely need some kind of middle ground here, right? Because those are the two extremes, if you will. We have great error detection and we have no error detection. Well, the middle ground between the two is occupied by fragment-free processing. And this processing makes the assumption that if there's corruption in the frame, it's in the first 64 bytes. And as you'd guess, that's exactly where fragment-free processing checks for problems. So with fragment-free, if no corruption is found in the first 64 bytes, the rest of the frame is assumed to be free of errors, and the forwarding process begins. You know, in a way, comparing these, it's like comparing TCP and UDP. Everything about one particular method sounds great, store and forward, that is, right? Well, if this method gives us total error detection and the others do not, why do the other two even exist? You know, why not always use store and forward processing? Well, the trade-off is time, but the time is not as much as it once was. And that, again, is why you see store and forward so often. So when we say store and forward is the slowest of the three methods, it's not horribly slow or anything like that. It just is technically slower than cut-through and fragment-free. Of course, cut-through is the fastest of the three because we're just, like I said, taking the frame in one port and shoving it right out the other without even checking for any problems. Now, again, let's go over the ups and downs of those three methods. It's worth reviewing. Store and forward has the best error detection, but it's the slowest of the three. Cut-through has no error detection and is the fastest of the three. And then fragment-free, the middle ground in both level of error detection and time. Now we're going to start talking about these virtual LANs I've mentioned once or twice here, and don't let the word virtual intimidate you. For one thing, we're living in a virtual world out here in networking now. I mean, we've got virtual servers, we've got virtual everything, so you got to get used to it. But you'll see very quickly, VLANs are simple to create, they're easy to work with. They're going to also be all over production networks you work with, and they're going to be all over your exams. So we're going to talk about the theory a little bit, and then we're going to dive into a lab on live Cisco routers and switches. Now, one major reason that we create VLANs, it goes back to a default switch behavior that we've mentioned several times to this point, and we know what that is. First off, those two default switch behaviors that give us a headache. All hosts connected to the switch are on the same physical LAN. So, okay, that's fine. The problem is when a switch receives a broadcast, it sends a copy of that broadcast out every single port except the one the broadcast came in on. Now, as we mentioned, we talked about this earlier, with a 4-host network, that's not too much of a problem. The real difficulty is we don't have many 4-host networks today. If that's a 64-port switch, certainly in the realm of possibility. 63 hosts are going to get a copy of the broadcast sent by any host on that switch, and it's very unlikely that all 63 hosts need that. So there's a lot of waste going on there. As more and more hosts are added to the network, you end up with more and more broadcasts being propagated. And soon, what can happen here is the switch is so busy handling broadcasts that it can't carry out basic switching functions in an efficient manner. And the network ends up slowly coming to a standstill. And this continual gradual increase in broadcasts is what we call a broadcast storm. And it can definitely sink your network. Now, it's not like a thunderstorm where it just almost comes out of nowhere or rapidly develops and then you have the storm and then it moves on. It's not like that. Broadcast storms happen gradually, because broadcasts tend to beget broadcasts, especially if you're not limiting them with VLANs. You just got broadcasts flying everywhere. Well, as you add more hosts to that switch, you've got more and more overall broadcasts. And again, it's a gradual degradation of the switch's ability to do its job. And what happens is you'll have some end users, complain about the network being slow. And I know there are end users and there are end users, right? And let's just be realistic here. You've got people who complain all the time. If they win the lottery, they'd start immediately complaining about the taxes. So you've got those people, but then you've got people who are really good to work with and don't complain a lot. So you have to watch who you're listening to there, of course. But if people start saying, hey, I noticed the network's slow at this time of day, whatever, you might want to check this out, because it indeed could be just that your switch is handling a lot of broadcasts. Now, to illustrate exactly how virtual LANs are going to help us out with broadcasts, we're going to run this particular lab. And you might want to jot this down too, and this particular IP address range, because what I'm going to do is set up a lab where we've got 4 hosts connected to our Cisco switch. Host 1 is on port 1, host 2 is on port 2, and so forth. And I'm using the 172.34.34.0/24 range of addresses. And if you're not familiar with that /24 yet, if you haven't watched that part of the course, that's fine. The key is they're all going to be on the same subnet. Now, we're going to use pings throughout this course to test connectivity, because when it comes to troubleshooting, that's just about the first thing you're going to do anytime is just test the connectivity. Is there basic IP connectivity here? Now, if you haven't seen a ping before, you're going to see one here very shortly. What we're doing is we're sending out 5 ICMP packets. And we send these 5 packets to a given IP address just by typing ping and then the IP address. If the packets reach their destination and come back, we're going to see exclamation points. And we like exclamation points in this business. I hate sentences that end with 5 exclamation points in email, but I love seeing 5 exclamation points on my screen. And much more on pings throughout the course. I'm going to teach you everything you'll ever want to know and might not even want to know about pings. These are the pings on the board, actually, and what it's going to look like when we hopefully have our success. Now, we're going to come back to the board once or twice and look at that diagram, but I really want to do this one on live equipment. So if you do purchase the study guide, you'll see all these readouts here. But here in the video course, I want you to see the video of it actually happen live. So go ahead, just jot that one down or write the addresses down on each particular host, and I'm going to go set up the lab, and we'll hit it next. See you on the next video.